Welcome to The Cynical Developer, the podcast that helps you to improve your development knowledge and career through explaining the latest and greatest in development technology and providing you with what you need to succeed as a developer. We've recently launched our Patreon page, which can be found at cynicaldeveloper.com/Patreon. If you aren't familiar with Patreon, it's an easy way for those who are interested in this show to help out by simply pledging a small amount each month in sponsorship. Now that could be as little as $5 a month, which is about £3.80, or as much as you like. You will enable us to dedicate more time creating more content to help you, including videos, more blog posts, and even more shows. So if you can, head over to cynicaldeveloper.com/Patreon and get involved. In this episode, we continue our extended dive into AI with Ed Yau. This is part 2 of 3. There is sort of some talk around at the moment about this AI bubble bursting. Is there anything to that, do you think?
Well, I think the problem that we're seeing is that the reality of the technology is not perhaps what it's perceived to be. And when there's that gap, then I guess it can create disillusionment. But basically, a lot of this AI hype has been driven from the press. So if you sort of listen to views of the really long-term practitioners, I'm not talking about, during those sort of people who are long gone, but people who've been in it for 20, 30 years, what they're saying is even though it's been going since the 60s in effect, AI, mid-50s if you take it all back to the beginning, the sort of deep learning discipline that we've got now, it's not really considered a fully mature engineering discipline. So most AI teams effectively spend the majority of their time doing what is R&D and reinventing scaffolding, and there's more realism around this from academia and industry at the moment. Also, it seems to me, based on what's coming out in the journals, so I think I would describe it a bit like programming in the 70s, in that companies will love to invest because they think it's this amazing thing that's going to have huge paybacks, but the results aren't necessarily proportional to the investment in many cases. So in reality, as I said, AI started in the 60s, and many of the things that people are still doing, the basic 5 boxes I've talked about, things they basically invented in the 60s, and now we just have the benefit of vastly larger data sets and much more computing power, which makes some of these systems, these ideas work. So neural nets, for example, something that basically has benefited a lot from the big surge in the internet and big surge in cloud. So whilst this side of things is well understood by data scientists, my view is there's now quite a shortage of engineering people who don't understand enough how to productionize these things safely, and in accordance with what is basically a fairly constantly changing regulatory and legislative state. So we're basically short of the people from software disciplines who really understand how to make these things work in production. So, we talk about DevOps, for example. Well, DevOps in software is quite mature now, but DevOps in machine learning is still, well, how many DevOps engineers are you going to find who know about machine learning right now? There's obviously a shortage, isn't there? So, if you sort of follow the sort of predictions of what some people are saying around what AI will do in what they call the 4th industrial revolution, that's ultimately based on massive algorithm accuracies, like 100%, and it's also based on, I guess, having enough people to can actually implement these things. So I mean, in terms of the accuracies, you can kick it around. So if you've got an AI that's right in 90% of cases, is that good enough? So I was reading a couple of weeks ago that the first AI system to be approved by the FDA for diagnosing eye diseases was announced, and this was on the basis of a clinical trial over retina photos of 900 diabetic patients. And on that sample, it was able to accurately diagnose eye disease in 90% of cases. And apparently this is comparable with humans in real world conditions, just because we get bored, we get distracted, because looking at pictures of eyes is really monotonous.
Yeah.
And in their view, 90% was fine. So again, it's back to it being a tool, I suppose, for a doctor who would rather spend their time on doing ward rounds and things like that. But imagine if you had an AI that was only 9% right if it was driving your car or flying your plane. I think that would be quite scary, personally. So I guess diagnosing eye disease is quite a specialist thing, but it does raise an important point. But in terms of the bubble burst thing, the world of AI is known for bubbles and bursts, to the extent where there's even a term for it called the AI winter. So basically, when an AI winter happens, no one's going to pay for research anymore. That funding dries up, and everyone has to get normal jobs. So that's happened 3 times. So beginning of the 60s, mid 70s, and beginning of the 90s. So that's why I guess again, the press tend to get wind of things and overblow them slightly too soon. So I think my view is, even if it does sort of pop, it might stop some of the really deep AI research that's happening at the moment. But if we go back to the original definition of AI that we settled on, it is so pervasive, it's basically everywhere. So you can't see it going away. And it's definitely not just a fad, because we mentioned Amazon. We also, every time you go on Google and search something, it profiles you, tracks you across websites. In our homes, we've got things like Alexa, Cortana. So only a few weeks ago, I think Sony announced this. My Alexa just thought I was talking to it.
Yeah, I muted mine earlier.
But only a few weeks ago, Sony unveiled a new version of its iBo, which is like, if you remember back to like the 2000s, it was a toy dog, but now they've got a self-learning and autonomous version that's much better.
Yeah, I always wanted one of those.
And there's a company called Anki that is doing something called the Vector, which is it is a fully autonomous robot toy. So it can see, it can hear, it can sense emotion, it can move you around your house, obviously can learn the shape of your house, it can show personality for facial expressions, and that's only £200. Oh. So, so if you can't afford an iBo for like $2,500 or whatever it is, you can get an Aki, and it's not even that much. So if you go to Tokyo Airport, they've got robots greeting you when you get off the plane. You've got companies like Google's Waymo. You've got Uber, who try and do self-driving cars. They've done millions of miles in testing already. And really the only thing that's holding them back is the legislation. I guess people's comfort levels don't let them do it. So if you're saying, well, let's just forget about all this AI stuff, it's just a fad. Let's just come back in 5 years' time, it will be gone. I think that's basically completely unlikely, isn't it? So I think as developers, for building these systems, these software systems, we certainly can't dismiss it as a fad, because if we do, then it's hard to be relevant in our industry. But conversely, if AI is to fulfill this massive hype, it needs loads more developers to actually apply their engineering skills to make these things work properly. So I think that's my standpoint about what's going on. I think what you read about in the press, you have to analyze a little bit, and sometimes you have to take it with a pinch of salt, don't you?
Yeah, you definitely do, and people claiming that that certain things are a fad, I'm always very wary of that. And in my own sort of career path, very early on, I was told by we'll say an educational practitioner that I shouldn't bother getting into computers because computers were a fad. It wouldn't be a good career choice, and there would be no jobs in it for me in the very near future. Well, sort of. I think that person was wrong. Yeah, you're talking 20 years later, and I'm still working in computers. It's.
I wonder what they're doing.
Yeah, I don't know. Probably still developing and moulding the minds of tomorrow with their pearls of wisdom. But that's maybe me being a little bit cynical.
See what you're doing that.
Yeah. But I think a very poignant thing that you said there was about the accuracy of it. Yeah, 90% diagnosis by looking at scans of eyes to find eye disease. Fantastic. 90% accuracy that you're going to get me home in the automated car. Not so good, especially with all the commuting we have to do. So I guess the percentage of myself driving myself home of an evening from work, the percentage of me getting home without being involved in an accident is probably not a million miles away from that 90%. But when you put it down, I'm not saying I'm a bad driver, but when you put it into that figure, 90% chance that your car will kill you on its way home is absolutely terrifying. So we talked about it being scary, and we've talked about these different types of definitions about AI and stuff. AI can be frustrating to work with, I guess. Have you got anything you can talk about on the frustrations that we're going to have with working with AI?
Well, I think my observation is that because everyone's talking about AI, everyone wants to do AI. So one of my colleagues was talking about it recently. I think he was talking about blockchain actually, but basically it's like teenage sex. Everyone's talking about it. No one's really doing it. So I think there's a perception that there's a bit of that with AI as well. Some of it is because data is really hard to come by, as well as, we talked about the skill shortage, but in reality, unless you're Twitter, Google, Facebook, Microsoft, you probably don't have that much data, and the data you have, you're going to have to spend, if you imagine that you're incepting this machine learning project tomorrow, roughly half the work in that project will be spent by data scientists just getting the data into a state where your machine learning model isn't going to basically draw a completely useless conclusion. Then you might spend another quarter of that time trying different algorithms to see which one works the best on your data. So a bit like a top trumps thing. And then once you've figured that out, you've got something that is a proof of concept, which seems to work okay. Then you've got to figure out how to deploy the thing, how to do the DevOps side of things, and how you keep it safe from running in production. Because if it gets corrupted, if it's a black box, how do you fix the black box?
Yeah. Because once that data's gone, it's gone.
Yeah. So I led a team at Microsoft AI Hack a few weeks ago, and our brief was to try and come up with a really cool way of helping our developers do timesheets just by looking at their Git commits, really. But I think the biggest frustration on that project was, I don't want to spoil it too much, but because we're still doing, at some point we're doing a blog post to talk about it in a bit more detail. But the biggest lesson we learned was when people in AI say data is your oil, it is literally because if you don't have it, your engine won't run. As in, you must get your project started if your data isn't in a compatible form. So I guess from this you can probably understand where most of our time went on this hack. And it's it's one of those things. So I think that's the biggest thing for most companies who want to do AI. They'll won't really have the data in a good state, and therefore, again, back to your kind of inconsistent value out of your investment. If your data is in a terrible state, you might spend all your money just getting to the point where you can start. Whereas your company down the road who's got a data architect and has been keeping data clean for 15 years, they're instantly straight in, aren't they? So, but from the outside, you'll have no idea what state you're in until you start having a go.
Yeah, and I think on that data sort of side of it, I guess with like the likes of image recognition and stuff like that, that take that down to a basic level, that your algorithm's running and it's looking for cats in photos, for as an example. It's going to go through and say, yes, this is a cat, no, that's not. And then somebody actually has to sit down and go, yes, you were right, no, you were wrong, through that set of data. And that, I guess, by no means is going to be a small amount of data either to churn through to make sure that it's actually making these right assumptions.
Yeah, so there are ways of bootstrapping it. So what some people do is they basically apply existing algorithms on top of their data to do the labeling, and then they'll get someone to review those. There's little cheats, but let's go back to the 25% spent on trial and error. So Ali Rahini, who works for Google, is an AI researcher there. He won a prize last year from an institute called NIPS. And he stood up and in his acceptance speech, basically, he compared the state of AI research to being akin to alchemy. So rather than being a science, he's very critical, actually. He actually said that most researchers were just fumbling in the dark. Yeah. So just doing trial and error, not really understanding what's inside these black boxes, because it's all very opaque. And one of his examples was, he found like a class-leading algorithm, and then his team basically spent the next week or so taking it apart, stripping bits out. And when they finished stripping bits out, it was even better than when they first started.
Right.
So all these different bits that are bunged in on the ends weren't really doing much for the algorithm. So I suppose when we're talking about these black boxes that we're putting together, it's basically even the real experts are still struggling right now. So I mean that's not to say you can't get really amazing results. It's just that I think, in my opinion, you need some strong human oversight in certain places, and certainly with you will have heard of GDPR, which came in this year. One of the stipulations is if you are doing any sort of profiling with personal data, you need to prove why and how you've done it to show you've not got any bias. So this is actually quite a difficult problem for machine learning, because as you said, these are black boxes. So it's hard to explain why these things behave the way they do by just looking at the structure of them. It's not like being able to read through your code and doing a really in-depth code review and following it through and debugging it, because you can't, not certainly with traditional software development methods. But even as engineers, I still think if you can't explain what the box is doing, you've really got a problem, haven't you? Because you don't really understand how your software is working, and these are all software systems at the end of the day. So there's an area called Explicable AI, which is obviously, because of all this, quite hot at the moment.
So you mentioned then Explicable AI. It's quite a bit of a random term. Do you want to go into some detail as to what that is?
Yeah. So if you've ever seen a picture of a deep neural net, a visualization of it, you'll basically see that there's no way you will ever understand what it's doing, because it'll literally be a load of nodes with numbers against them. Those numbers will be weightings. So there's no structure in there that says, this, you fit in these three things, you get this one thing out, and this is why. So that's why it's tempting to think of AI as a black box. So Explicable AI is basically a machine learning research area to help humans understand what's going on. So the sort of best known technique in this area is called LIME, which stands for Local Interpretable Model Agnostic Explanations. Again, just another mouthful of jargon. But basically, if you consider you might have a classifier algorithm that takes 5 features and outputs 1 value. So just like any function that takes in 5 parameters and produces 1 output. So what LIME will do is it will randomly exercise different values in those 5 parameters. It will change one. It's like the old scientific method in school. You change one variable and you find out what one variable does. And what LIME does is use this to find out which features have the biggest effect. And it'll give you a visualization that explains something that you'll understand as well. So I would look at what it does as something a good software tester might do if they're doing something like exploratory testing for you on your system, but it's completely automated. So there's something to be said about that. So funny example I read about was where something like this was really helpful was a team who was trying to get some insight into what time of day it was from just looking at pictures of a railway platform. So their sort of hypothesis was you could do this from the lighting conditions, whether it was light or dark, and by how many people they could see standing on the platform.
Yep.
And they managed to get some quite frankly amazing results, like almost 100% accuracy. They were blown away, as you might imagine, because they thought they just invented something amazing. When they ran LIME over the model, they realized that actually what was making it work this well was right in the top left-hand side of the picture. There was a little mirror where you could see a clock. So it was just using that.
The algorithm had seen there was a clock in there and read the time of it.
Yep. So if you've gone away and just thought you'd invented this amazing platform that could look at any picture and tell you what time of day it was, then you could, but only if you could see a clock in it, basically. Which is a bit defeatist, isn't it?
Yeah, I guess so. There are easier ways to get software to tell you what time it is. So with all these different sort of avenues that there seem to be for AI, what's the best way for people to get into it? To start becoming AI developers.
Well, there are lots of great resources, but I think I would sort of describe AI as like a pyramid. So if you want to start at the bottom of the pyramid, which is it's really easy, if you just go and search for cognitive services in your favorite search engine, whatever that might be, you'll turn up all sorts of cloud services from Microsoft, Google, IBM, AWS, people like Stanford or Wolfram. These are just REST APIs. So effectively, you've had a data scientist who's built a model, trained the model, and you can then use it as plug and play.
Yeah.
Obviously, there's a little bit of a fee involved in each of these services, but you're firstly skipping 99% of the effort.
Yeah.
Because you've gone straight in off someone's hard work.
Yeah. Yeah, I've had a little bit of a play with Microsoft's cognitive services at Hack24. I was trying to use the facial recognition to work out the mood and things, and I've decided that their cognitive services were rubbish and biased. against me because it said I was like 15 years older than what I was consistently. Take from that what you will. And it also it said that I was constantly surprised. No matter which face I pulled, it said that's a surprised expression. But who knows? Who knows?
So I think if you want to have a play, that's a good place to start, just so you can start figuring out what these 5 building blocks really do and how they work. If you want to go to the next layer up, these companies now have cloud-based services that allow you to train their own model on your own data set. So by doing this, you can get more tailored results than those cognitive services. So basically, back to your example, James, of pictures of you, you could there's a service called Custom Vision API now that Microsoft have. You could train it just a picture of you and tell it all these values, and then you can get exactly what you want.
Sure.
So you don't. So that's the next level up. Still paying Microsoft a bit of money for that service, but when on the general purpose cognitive services don't give you what you want, then these are the next place to go. Because I think if you look at those cognitive services, they all give you a huge amount of information, most of which you're not interested in, because they've almost got they've got multiple classifiers, or they've got classifiers that are able to take do multiclass. So very, very, very sophisticated things fed on billions of terabytes of data, but not necessarily tailored for what you want to do. So I remember I went to DDD Southwest. I gave a bit of a machine learning talk, and I just built a hot dog classifier. I don't know if you watch Silicon Valley, but using something like Microsoft Custom Vision API, you can do something like that in 10 minutes. All you've got to do is find lots of pictures of hot dogs.
Right.
So I mean, that's so if you're doing something like that, it's good, and it's a very fast way to show what it can do. So that's the second tier. If you think of the next tier up, if you go on GitHub and you're looking for these models, you can actually host them yourself in a container. You've got to build your DevOps workflow, and you have to provide your own data. But if you're working somewhere where you've got very strong compliance concerns, you don't want your data going to the cloud, then you can basically host it yourself on your own server in private. And by doing it this way, you can tweak and optimize what you've got as well. So this is a good way of starting if you know roughly what you want, but you don't want to basically spend 6 months learning data science. So you're using someone else's model just on your own hardware. And then I suppose right at the top of the pyramid, in terms of difficulty, is basically, if you're a data science PhD, then you'd always go to the top level, wouldn't you? There's no way you use someone else's stuff.
Yeah.
So those are really the sort of 4 levels that I see. And the sort of first 2 are pretty easy. You can get going in those in a few hours, less to be honest. But I think if you're like myself, then you'll find yourself wanting to find out more. So in terms of courses, you've got so by the way, anything that I mention, I'll ping the link afterwards so that your listeners can go directly to these for themselves without having to take loads of notes.
Yeah, sure. We'll get all those in the show notes, so you can link through to them, because there's definitely been a lot of references to things already so far.
Sure. So Fast AI have an excellent MOOC. One of the most famous ones is Andrew Ng's Coursera course on deep learning. So Andrew Ng was obviously famous because he used to run Google's data science team, and he created Coursera as one of his platforms, and he's created, personally created courses for it using his knowledge. And Google their own nanodegrees. So one I've been doing recently is on edX. It's an AI course from Microsoft. So I'm doing it because I want a Microsoft AI certification. But all of these are as good as each other. Microsoft themselves have an open source machine learning book that has been written by their cloud data science team. But personally, the best book I've read on this subject is one called Thoughtful Machine Learning with Python. And it's by someone called Matthew Kirk. And the reason I like it personally is because it comes very much from a software rather than a machine learning focus. So he's very much trying to solve the business problem. He just goes into all the machine learning on the way. But at the end of the day, we're all in the business of creating software here who on this podcast. But the most interesting thing about the Kirk book is because basically he says, well, machine learning is alchemy, but if you match it with some TDD and some engineering, then you've got something that meets your rigorous engineering requirements. Because you've got a requirement, you build it, and you build a load of tests around it at the same time. If it passes those tests, as far as you're concerned, the black box does what you need it to do, and you keep running those tests as you go. And as you put more data into it, you can keep rerunning those tests again, and that brings it out of the land of magic back into engineering. So most of these courses are Python, so it's worth brushing up on that. But Python's quite a simple programming language, so if you can do anything else, it's probably quite easy for you to pick up. But if you're a .NET developer, then there's other options. So Microsoft recently released something called ML.NET, which is a machine learning library for F# and C#. And then if you've got a sort of more of a JavaScript background, you've got options as well. So, but ultimately the hardest part of learning about AI, if you're not from more of a data analyst background, is understand how all the stats work. So that's another area that you should probably have a look at. I think my point about all this AI deep learning stuff that is cool right now in machine learning, unless you've got a huge amount of data, like millions of records, a lot of the simple algorithms will give you basically the same result. So things like decision trees or SVNs or Bayesian models, these are just all stats methods, but they'll give you the same results as a deep learning algorithm, unless you have lots and lots of data. So that's where the reason why deep learning has sort of done well over the past few years, the explosion of the internet, Twitter, Facebook, and Google, is because the classic machine learning algorithms sort of top out at a certain point, but with deep learning, basically they keep getting better. So the more data you throw at it, the better it gets. It will taper off over time in terms of how much better it gets, but they don't really plateau in the same way. So you can get up to those 90% accuracies, or close to 100% accuracies if you get enough data of the correct format. So that's I suppose why it's being taken more seriously these days.
Yeah. It definitely sounds cool, and but it does sound like there's a lot of things there that you've got to work with, a lot of things you've got to work out before you dive in. But why should developers really be getting into AI? What's the immediate benefit?
So I suppose if you're a developer, you're naturally one of these people who likes things that are new and shiny. So if you want something new and shiny that's a bit different, this is a good way to to keep your brain engaged. I know there's a converse view that if you know one thing, you do it really, really, really well, you'll still be really successful. So there's going to be plenty of work for web devs until we retire. And I've seen those those top dollar contracts at these banks where they're paying COBOL developers thousands of pounds a day to work on these legacy systems that were built 30 years ago, just because there's no one else anymore.
Yeah.
So there is a certain payback from being that wax on, wax off guy and just being a real ninja at it. But I suppose my viewpoint is slightly different in that I work at a slightly higher level these days. When you're a solution developer, we're a solution architect. We are building software to solve a business problem. So the more business problems I can solve, I suppose, the better I can do my job.
Yeah. And so I like new and shiny. I suffer with new and shiny syndrome constantly.
Yeah.
Of what's this? Can I do this? Okay, I've looked at that for 2 minutes. Oh, what's that over there? Pigeon. Because I want to get in and get stuck into it really quickly. I don't tend to want to have to read around too much on things, and going and learning data science, learning about statistics, and that seems like a whole lot of hard work, really. I've got to really use my brain. Is there sort of like an easy route into it that I can just jump straight in and start doing stuff?
Yeah, so if you find a framework, those frameworks will come with tutorials. I think the sort of hello world of data science seems to be some data on the passengers of the Titanic for some reason. I don't know why that is, but it just seems to be one of those.
That's only going to end in disaster.
Yeah.
Spoiler alert.
Exactly. So you can go down that route, but if you don't do a bit of data science, you're only going to get so far. So you can understand the black box, you can plug them together. But if you ever want to make your own black box, you're going to have to go deeper. So in terms of equipment, first thing you need is a PC with GPU. That's tick that box. You can do stuff in the cloud, obviously, but if you're just experimenting, you don't really want to be spending all your credits on spinning loads of GPUs up and spin them back down again.
Yeah.
So it's just easier to do it locally. So as I said, most of the courses are in Python, so it's worth having a go at that. But if you go deep learning, you got things like you got libraries such as Google's TensorFlow, but that's just a horrible developer experience. The main problem with it is that it's designed for building neural nets in a static way. So once you built it, you can train that same structure with as many different data sets as you like. But if you want to tweak it, you want to experiment, you want to change the network, basically have to go in and change your code and sort of almost start again. You can't do anything at runtime. So you've got things like other libraries that work better at a high level abstraction. And they're much more flexible. Things like Keras, PyTorches from Facebook. Sorry, almost got that wrong. So they're a good fit if you want to learn Python. But as I said, if you're a JavaScript .NET developer, there are other options too. So Microsoft's ML.NET is your obvious .NET developer's route, and it sits at the sort of same level as Keras's PyTorch, slightly above your TensorFlows. It's actually the same code, believe it or not, they used to build Windows Hello, all that snazzy recommendation engine they've used for the PowerPoint slide design recommender.
Okay.
So it's real world code they've open sourced, so developers can get involved. And I think if you look at the architecture, it's actually quite nice. They've designed it to be extensible. So they're looking to implement TensorFlow as an extension at some point in the future. Another one I found, I've not looked at in depth, is Accord.net, which appears to be well regarded as a much older framework. But again, you can basically plug in some black boxes in your .NET code. and you're away. So if you're a JavaScript developer, there are versions of TensorFlow and Keras that will basically just run your browser without installing anything at all. There's loads of cool demos you can find on the internet, and I think the latter routes also have some advantage because all your code is running local on your device anyway. So from a privacy perspective, that can be helpful. I think because I think a lot of people are just paranoid about where their data's going these days. So if you're building an app, if you can somehow not keep that data in the app, that's probably quite a good selling point these days.
Sure. Yeah, it's I'll have to have a look at this ML.NET. I have had a play with TensorFlow probably 2 or 3 years ago, and had no idea what I was doing, got absolutely nowhere with it, and gave up on it. I went and looked for the stuff a bit like the Microsoft Cognitive Services that are in the cloud that you can just hook into and use. But as you say, that starts costing you money, and if you're just having a play, then that can get quite expensive quite quickly, and that's money coming out of your own pocket.
Yep, exactly. So I think these libraries are sort of getting to the point where it's not quite as easy as those cognitive services, but you can get a little bit beneath the hood with them in a way that you couldn't really do before without a lot of effort. So I think gradually the barrier of entry of all this stuff is coming down and down. So I think it is relatively realistic for most developers soon to have some appreciation of what's going on. And it's just whether you've got projects where you've got that data readily available. But if you want to have data for play, there's a lot on the internet. I think Google recently released a new sort of search engine just to be able to search for data sets.
Yes, yeah.
So that's quite exciting from that perspective. So if you just want data, there's loads of it out there. You might just have to clean it up if it's completely raw.
Yeah. It's I think it's like with absolutely everything now with our development careers is that we're always standing on the shoulders of giants, but it's just very early days for AI. So those shoulders aren't that much higher off the ground than our own at the moment. So that's it for this week. Make sure that you tune in next week to find out more about AI with Ed Yau as we continue our journey. But for now, thanks for listening to The Cynical Developer. I'm James Stoddart, and you've been listening to Ed Yau talking about AI. If you have any questions about this or any other episode, then drop us an email, a tweet, or leave a comment on the website where you can find all the resource links, show notes for each episode. And if you enjoy this episode, please leave a review on your favourite podcast platform, iTunes, Stitcher, whatever it is, and help The Cynical Developer to reach more developers around the globe.